So good evening, I'm AK Arora, working with NTPC as GM SIS, Strategic Initiatives and Information Systems, the Department in Operation Services. I'll be chairing this session. We have three speakers with us and all the three very relevant and contextual topics. We have Mr. Manas Negi, who will be talking about the use of drones. We have Mr. Ilan Sasovich, who will be talking about cybersecurity, and we have Mr. Rahul Raghunathan, we'll be talking about artificial intelligence for flexible operations. Drones are being extensively used in power sector for inspection of transmission distribution lines, for inspection of solar panels, wind farms, surveys in coal heaps in our plants, for inspection of inaccessible areas, boiler, chimney, and of course for monitoring progress without any risk and hazards. I'm sure Mr. Nagi is going to elaborate on the same. You may start, Mr. Nagi, please.
Thank you, sir. Thank you so much. Good evening, everyone. To begin with, I'd first of all like to thank the Confederation of Indian Industry to give us this opportunity to come on this platform and speak broadly about drones applications in the power industry. So, wasting no further time, I'm going to jump onto a brief about the company IdeaForge. So we are a total Make in India firm, and we are present in Navi Mumbai, New Delhi. And with the production facility in Navi Mumbai, we also have service centers in Chhattisgarh, Jagdalpur, and Udaipur, Jammu. We are, as I said, when we say totally Make in India firm, we do all the R&D, design, testing, training, everything here in India. And we have multiple IPs, which also includes the one that will be reflected in the presentation further on, is the autopilot. Moving ahead, the UAV design for IdeaForge, or the unmanned aerial vehicle, is separated into components. On your right, what you see is the drone. That is the bird, basically, that will take up the specific payload, capture the data. And on your left, what you see is the ground control station, which has a high range communication box. Now, having this kind of setup gives us a rather advantage when we talk about tight geometry areas or the urban areas for that matter. So the UAV in a true sense is rather a combination of these two components, wherein the ground control station receiving the data and drone being the capturing data aspect give us that data set or the end output deliverable that is by far the useful information. Moving ahead, when we talk about drones, like Sir just mentioned, drones can do or are capable of doing multiple things. So with drones, there is a certain sense of modularity that at one point of time, you can have a certain payload doing a certain job. For instance, when we talk about monitoring, the daylight video payload gives you the live feed that gives us the details of areas that are sometimes inaccessible or relatively in areas that has a limited reach. Then photogrammetry is the place wherein the applications such as mapping, such as volumetric analysis, 3D, 2D models comes into picture. Then, of course, we we heard Sir talking about the inspection parameters. So that's where a radiometric thermal comes into picture, wherein you can use this particular payload to inspect solar panels, to inspect vertical structures, to also inspect assets that are rather utilized or are functioning for a longer periods of time. Then, of course, we also have options that are relatively towards night surveillance, which is the black and white thermal, and the multispectral camera, which rather comes in handy when we talk about functions that are relative to agricultural inspections. Jumping on to the first application that I want to discuss is the volumetric analysis. So when we talk about any production facility, and I mean, sir comes in from NTPC, where coal is rather the most crucial aspect of this function, wherein coal being the raw material is the function with which we defined for how many days or what kind of output or what percentage of output is going to come out in that particular certain period of time or with that particular amount of raw material. So the volumetric estimations, the challenges are usually the part that it's a crucial aspect. We need to do, or we need to have accurate measurements, higher frequency of service, and at times there are certain landfills that are right underneath these raw materials. And when we talk about the conventional methods, it does add to the certain level of errors. Now, when we talk about drones does these kind of calculations with thousands of data points, which means it adds to the accuracy levels that it tends to produce. Now, drones, they tend to do these jobs in times like 40 minutes or 50 minutes, which means these jobs or these activities can be done more regularly. And like I said, as drone takes up thousands of data points while gathering data, we get the result which is rather more accurate when compared with conventional methods. And because when we talk about payloads such as photogrammetry payloads, it has the option of creating both the uh, digital surface and digital elevation model. It gives us the ability to reduce the errors that are produced because of the landfills or the depressions that are sometimes right underneath the coal stockpiles. Moving on, the next application that I want to jump onto is IR inspections. So, like I mentioned at the slide when we were talking about different payloads, the there are certain parts of the assets or facility that are running day and night. So these could be pumps, these are transformers, these are vertical structures like chimneys, these are transmission towers. So there is a certain sense of safety hazard that are involved. So we tend to have challenges that are relative to labor values, to what accidents. And then at times when we are doing such inspections, we need to make sure that there is a certain amount of, you could say, we need to have sometimes wait for things like shutdowns. Now, when we talk about drones, because they can manage to gather data from a distance, we still can do these activities while the facilities or these functions or these assets are still up and running. So it gives us the option of identifying things like tears, connection losses, structural defects, corrosion effects, thermal leakages for chimneys, and fault detections for things like transformers, vertical towers, transmission towers, etc. Now, the next application that I want to talk about is actually an extension of the IR function or the IR inspection function, which is the solar panel inspection. Now, like we initially spoke about it, a lot of power industry giants are now looking towards renewable energy as the source of green power or green energy. So these days, what we tend to see that the first and foremost choice for this particular aspect is usually solar panels or solar power industry. So for such functions, it is usually spread across large areas and there are land and mapping aspects attached to it because the challenges that come into for these inspections or maintenance of these assets is usually the fact that we have to manage and inspect each of these panels individually. And these adds to the time that is taken for such inspections. Then to maintain continuous production, we need to have accurate values of such anomalies. And if at all, we look at the way these panels or structures are usually planned, they tend to leave a large amount of area between the panels, for instance, to run vehicles around them for inspection purposes, for the same. So when a drone comes into picture, the drone can accurately fly right above these panels, gather the data, and also produce geotagged data sets, which means that when we are talking about certain anomalies that are to be mapped, we can individually identify these panels and look at the corrective measures independently. And then, of course, these things or these activities are now done by drones. They are taking relatively less time. These activities can be repeated regularly. And of course, if we actually define the fact that we are going to stick to drones for doing such jobs, we can use more of land and reduce the amount of area that is tend to be left out for free vehicle movements. Then the next aspect that I want to talk about is the inspection of vertical structures with respect to the photogrammetry payload. Like for instance, we talk about structural defects, we talk about cracks, we talk about certain risk assessment. So this is something that usually comes into picture when we talk about transmission towers a lot. So the usual method of doing or the biggest challenge I believe of doing certain inspections is the fact that most functions tend to switch that particular grid down so that that particular tower is accessible for humans and labor. And you can have those scaffoldings, you have the gears wherein people or humans have to climb and individually assess each towers. Wherein in terms of drones, they can actually gather such data even from a distance, avoiding the magnetic interference that is produced by these high voltage lines while doing such an inspection, which means we do not have to shut down that particular grid or that particular line for inspection of such towers. We can do it from a distance. This can be done with limited human interference. And the added fact, because we're doing with drones and it is taking less time, these objectives or these things can be done rather more regularly. Now, the final use case that I want to address here is the security and surveillance. Now, when we talk about industrial facilities, the production facilities, or even solar panel facilities, these are spread across kilometers of areas. So we can come across perimeters that could be 15 and 20 kilometers or so. And the challenges are relatively the lack of human to cover these areas. And even if we talk about foot patrols, we are limited to the accessibility, we are limited to the daylight, and we are limited to the fact that these information has to be directly fed to the control and command centers. Now, when drones come into picture, because we have a bird eye view, the drones can pretty much access the areas that were rather inaccessible by human intervention. Now, if you look at the said screen, you'd see a video of drone following a certain navigation, a certain pattern. So like in the second slide, we talk about IP of autopilot drone. So the drones today are flying on completely autonomous fashion, which means we define the waypoints of such territories, of such surveillance activities. We save these files, and every time what we have to do is just load these files, double click, and the drone follows these instructions. And these instructions could be as minute as spending a certain amount of time at each waypoint that we define. How quickly can we add a waypoint? Well, it's as simple as right clicking on the screen and adding a waypoint. Now, because it is that easy to manage, you also have the option of feeding this live information to the control and command center, wherein someone sitting at the office or maybe someone kilometers away sitting in the headquarters also has the same live feed on his phone or maybe on his laptop and take direct actions on any activities that are happening. And like we initially said, the drones are also capable of putting up a nighttime surveillance payload, which means we are not limited to the daytime or the daylight for conducting any such activities. And even at night, if at all there are situations where area needs to be monitored, a drone can go up with a nighttime payload and very well do the job. Uh, that pretty much would be all that I would want to address in this presentation. I thank again the Confederation of Indian Industry to give us this opportunity to be on this podium and speak about this technology. Over to you, Arora sir.
Yeah, thank you, Mr. Nagi. Thanks a lot. That was a very effective presentation. We'll have questions at the end of the three presentations. The second presentation is by Mr. Ilan Sosnovich, a very contextual and relevant topic. On 12th of August of this month, that was a festival day, Janmashtami in India, there was a long blackout in Uttar Pradesh, the whole of state, because 2 lakh smart meters, they got a wrong command from centralized control. Nobody knows why. There have been numerous other instances of cyber attacks worldwide, Ukraine, USA, Korea, Iran, that actually affected the grid operations. And with more and more digitalization of power sector, it's becoming really vulnerable to cyber attacks. And then I feel that somehow in India, the awareness levels are very low, and we need to further invest in security infrastructure and protection mechanisms. So, Mr. Sasnovich, over to you, sir.
Thank you so much. I hope you can hear me well. Thank you for that introduction, by the way. So you gave a good part of the first introduction I wanted to speak about. Why is it so important to talk about cybersecurity at all? And thank you for that. Thank you for inviting me and for organizing everybody at the team at CII. My name is Ilan Sosnovich, and I'm the Global Sales Manager for Siga OT Solution. Siga was founded in 2015 in Israel by ex-cyber Israeli authority people from INCD and others, where they have implemented cybersecurity methodologies for OT environments, OT meaning operational technology, including for the power industry. And then they understood about the gaps that are currently available in the power industry and other industries as well. And then they founded Siga in order to bridge those gaps. And we'll discuss a little bit about the challenges of cybersecurity solutions for the power industries and others. So why is it so important at all to discuss cybersecurity? I've seen the agenda for this important summit. It's an amazing summit, I believe, including all these different aspects of how do we increase our productivity, how do we be more efficient with what we do, and that's absolutely amazing. However, cybersecurity is all about process resilience and continuity. We want to make sure that we have the ability to continue operating at all times. And your example for a few months ago from what you experienced in India, here in Israel, by the way, we had an attack on our water systems just this past April. So it all shows you how relevant what we're talking about is. Cybersecurity is not something far away, not something that we don't need to talk about. It's something that we do need to talk about. And if we are not proactive in our, I would say, mission statement about cybersecurity, then the premise for our operation is that we are vulnerable. That's how we need to consider cybersecurity. And that's why we need to be proactive. So in order to understand more about what needs to be done, let's try to understand what are the challenges in cybersecurity, why OT cybersecurity presents such a major challenges for us. And by the way, many of us know about cyber. When we talk about cyber, we mainly talk about over the years about IT cybersecurity and IT problems. However, OT can depict much more damage than IT bridges. OT is about operational technology, which means it can actually endanger lives. It can cost billions of dollars in damages in case there was a breach. That's why we need to discuss it and very quickly. So what are actually the challenges for us? The power industries, as well as others, has started its Industry 4.0 journey. And what we mean by that is that we try to connect more and more devices. The automation and control systems were once separate from open networks. And even if we try to separate them today, which we call air gaps, to try to separate OT and other enterprises as well, we are still trying to be more and more connected. We're trying to converge OT and IT together because we want to be more efficient. And this is a positive trend. We don't want to stop this trend. We want to continue this as much as possible so we can avoid downtime, we can increase our productivity and be more efficient. This is important. However, once we connect all these devices, and I heard once that today, every day, 20 million IoT devices are connected again and again into the global web. So I don't know how much of that is IoT, industry IoT. However, we are more and more connecting these devices. And this evolutionary transition exposes our mission critical operational processes to cyber attacks and other malfunctions. And we need to think about that. We need to understand what can be done. For safety, economical, and environmental purposes, the power industry must adopt a zero tolerance for downtime approach. This is what we need to aspire to, not some kind of, okay, if there's some kind of vulnerability, we can live with that. No, we can't live with anything. We need to have a zero tolerance for downtime approach so we can ensure our operational resilience and business continuation. In order to ensure operational and business continuity, our power operations require constant operational process visibility and situational awareness. This is the basis. We need to understand in every given moment, even if it's remotely from where we are. We talk a lot about that during COVID-19 situation where we're all affected by that, but we still need to incur our process visibility and situational awareness at all time. We need to try to prevent any unplanned downtime and detect cyber attacks and protect our critical OT assets. So why is this actually so concerning? The reason it's so concerning is because it's happening all the time. It's so relevant. Many talk about the 2010 Stuxnet attack in Iran as one of the first, I would say, major OT attacks that really opened up the world to OT attacks. And since then, there were many methodologies that and regulations that tried to close in the gaps for OT. However, they are mildly successful because we've seen over the whole decade again and again attacks occurring in the industry, also the power industry, oil and gas industries, and others. We can note even a few of them, such as the 2015 Black Energy attack in Ukraine, where the attack was successful to actually shut down turbines in a power plant, and 225,000 customers were without power. Another notable attack was just recently in 2018 in Saudi Aramco, where an oil and gas facility was affected by a very, I would say, notorious attack called the Triton attack, which incurred losses, revenue losses of over $1 billion. So the moral of the story here is that it's relevant, it's happening, it's now, and we need to understand what needs to be done in order to bridge the gaps and get things in place so we'll be ready if this occurrences will happen. So why is all this happening? What's so difficult about OT cybersecurity? The reason OT cybersecurity is difficult is because control systems were not designed with cybersecurity in mind. And this is a little bit mind-boggling because we're now in we're about, I would say, since the 60s or 70s, about 50 years into what we call the Industry 3 revolution, where we introduced all these PLCs, we introduced all these servers and controllers into our OT environments, and we want to make sure that our processes are automated and controlled, and that's very good. However, none of these control systems were designed with cybersecurity in mind. Even today, with unique, very good controllers by very good vendors, and you all know about these vendors, they will admit to you that they're not responsible for cybersecurity. So what is our premise? What is our assumption? We need to assume that our networks and PLCs are compromised. or will eventually be compromised. We need to assume that our networks and PLCs are vulnerable for cyber attacks. And there's so many vectors, there's so many ways where attackers, determined adversaries, can find their way into our networks, even if we have an air gap, even if we're not connected to the internet, through supply chains, through local attacks, any kind of attacks, we're able to infiltrate the systems if they're determined enough and they have enough resources, and attack our networks, attack our PLCs, and eventually compromise our systems and even damage them. So if our networks are so vulnerable, what can we do? And this is exactly where I want to put in the Siga solution, where we see things a little bit different and try to give a response for this kind of vulnerability in control networks. So now I'll dive in a little bit into the Siga solution. So the Siga solution actually relies on three different foundations. The first one on the left is where we are completely autonomous, because we understood earlier, if you agree with me, that our networks and control systems are eventually vulnerable and may be attacked by external forces. We want to have a solution that's completely isolated, completely independent and autonomous. It's detached from any network. That's the first thing we will look for you. And Siga is very unique also by the OT cybersecurity vendors available in the market by being completely detached from any part of the network. So we're not connected to the network at all. This allows us to monitor remotely and monitor very deeply our OT processes, completely agnostic to our ICS platform. The second foundation is reliability. We want to access the best source of data to have the granular visibility into our OT processes. And we do that at Siga by monitoring electrical signals, which is the deepest source of information, completely unfiltered and completely unhackable by hackers, because they're not part of the data world. They're not part of the digital world. So they are physical electrical signals, which allow us to access this granular data and analyze it in order to understand if we are under a cyber attack. The third foundation on the right is where we apply smart algorithms, artificial intelligence, machine learning algorithms developed by us in order to analyze these electrical signals, analyze the process, if it's a turbine, if it's a water system, if it's any kind of a peripheral system that's related to our process. We want an autonomous machine, an autonomous algorithm that will analyze this deepest source of information and detect any cyber-related anomalies and deliver actionable insights in order to understand and of course, react in time before something catastrophic will happen to our systems. So how do we do this? We do this by using our unique topology. What Siga is doing is acquiring electrical signals in between the critical assets, where we have all these sensors and actuators which emit 4 to 20 milliamps or 0 to 10 volts electrical signals to the level of PLC, where these electrical signals are digitized and go into the data world and digital world. And as I said earlier, we don't want to be part of the network because we assume that this network is actually compromised. We assume that attackers can access that network. That's exactly why Siga decided to access the lowest part of the OT architecture, what we call level 0 electrical signals, which are the deepest and most reliable source of data in the OT architecture. They are rich and unfiltered data. They are completely unhackable because the best hacker in the world can only infiltrate the data or the digital part of the network. He cannot infiltrate electrical signals because they're physical. So we actually created an environment which is completely isolated and completely detached from the network itself and cannot be manipulated by any adversary or by any attacker. That can give authentication and validation that what is actually happening in your OT process, in your turbine, in your substation, or any kind of OT process is actually the process is occurring according to design, and there's not some kind of malware that changes the OT process without us knowing it. How do we acquire these electrical signals? This is a very simple process where we deliver this box, which is very easy to integrate. It includes hardware electrical components by top vendors, which are very known in the industry, such as ABB or White Mueller or others, Well, they all have these kinds of electrical components, and these electrical components' mission is to duplicate unidirectionally the electrical signals into our platform uninterruptedly. So we don't interrupt, of course, with the OT process, and while doing so, we actually duplicate the electrical signals into our process in order to analyze them and understand what is exactly happening right now. Are we under an attack? Do we have an anomaly that needs to be considered? Once this box is integrated seamlessly into the installation, which takes about half a day to 1 day of installation only, we can already access anywhere we want real-time monitoring and granular visibility. So we are able to provide much more granular visibility into the system than any other part of the system because we access these electrical signals. We are also able to detect any pre-configured alerts that the operator wants to configure by himself. And even if he didn't do so, our machine learning AI detection capabilities will learn the normal process of the OT process and will alert if anything anomaly is happening, which is related to a cyber attack that we want to know about, of course, and detect. And this whole information or data or insights can also be consumed on premise, so not outside the site, but it can also be safely uploaded. And this was approved by cyber agencies to upload it to the cloud to also consume this data remotely because of our unique topology, because we're not exposing any part of the network. What is our actually value proposition by doing this kind of cybersecurity? Detection of pre-configured and hidden anomalies, cyber attack resilient, this is exactly what we're looking for. We are provide independent validation of PLC outputs so people will actually know what you're seeing in your HMI, what you're seeing in your screen is actually what's happening in the turbine or in the OT processes down in the critical assets. This is very important. It's a bulletproof protection against any kind of stuckness-like situation where there's an isolation between the HMI and the actual process. And we can validate that what you're seeing is what you're getting. We also provide data archiving, granular visibility into your system. Our installation is seamless, half a day kind of installation with intuitive UI. Enabler for as a service offering with also with flexible service pricing and regulation compliance. So we are very regulatory driven. So this is an example I just wanted to give you from one of the alerts that we were able to provide, which we call early failure detection, where we are able to detect something that's evolving in the system even before it becomes a major problem. So what you can see here are alerts that are issued by the Siga system minutes, hours, or even days before the actual breakdown of a system, before before the system evolves into something catastrophic that actually becomes into a failure. So just to summarize this section, what we see is that Siga Guard, the Siga solution that we offer, takes its insights directly from level 0, and this is completely unique to what we are doing compared to other vendors which are very good. However, they are all the common ground between them that they are all related to the network. They take their information from the network level. What we are trying to do, as I explained to you earlier, that we are trying to gain our visibility directly from the deepest source of information, completely detached from the network. We don't want to be a part of it because we assume that they are vulnerable. We packaged all this into the solution we call the Siga Guard together with our add-ons, including the Siga Guard Essence, Prime, and Reference, in order to comply and give you the best visibility and reliability of the system situation. As I said, we are very regulatory compliant or driven, and we provide anything needed in order to detect. We are essentially a detection company. So we try to detect these cybersecurity, which is actually the core of the NIST framework, as you can see here, to understand what is actually happening and how can I respond. We were also recognized by the Israeli Israel National Cyber Directorate, as you can see here, which actually inserted it in its recommendations to take also into consideration measuring the changes in sensors and actuators from level 0, exactly as Siga does. And we were also tested and verified by the iTrust in Singapore a very important institution by the Singapore University, where they tested various type of detection capabilities from different vendors. And what they found was that product D, as you can see here in their own report, Siga was part of product D. We were outperformed any other product. We had 100% detection rate and superior detection rates for other attacks. So in all the categories, the yellow bar you can see here is the product D. I know I'm going short on time, so I'll try just to give you a few use cases very quickly in order for you to understand where we were already operating. One example would be NYPA, the New York Power Authority, the largest public utility, power public utility in the United States, where we inserted our system and we were tested by them in a substation environment, and we were able to detect different anomalies, as you can see here. And they also provided us with an important quote by the CISO of this organization, where they said that our results showed promise in helping seal our infrastructure from any cyber threat at level 0 of any machinery, equipment, or process. Another example is from IEC, the Israel Electric Company, where we inserted our system, we integrated our system into a GE Mark V turbine. And here too, we were also able to show them how we can detect different cyber attacks that they induced into the system, simulated into the system to check if we were able to detect them. And they also provided us with a very important testimonial to testify for this results. So just to summarize, I think we all understand the importance of cybersecurity. And even if there's one thing I want you to remember from this session is that how important it is to be proactive in understanding the situation, bridging your gaps. And of course, if you can do it in a way that's completely isolated and detached from the networks, I think that's an important way to go. You need to go as far as possible in order to seal your infrastructure and make sure you're completely independent with your manufacturing and OT processes. Thank you very much for everybody for hosting us again. I would also like to indicate that if you want to contact us, we have our Indian associate available for you. As you can see, the details in the screen right now, Futuristic Technology Solutions, and there will help us to accompany any kind of question that you may have or clarification with our assistant. So thank you very much.
Yeah, thank you, Mr. Sosnovich. Because of this pandemic situation, cybersecurity is becoming all the more relevant nowadays. Thank you. We'll be taking the questions at the end of the 3 presentations. So we come to the last presentation of this session, and for this day, Mr. Rahul Ranganathan is going to talk about artificial intelligence and its applications and flexibilization. AI is something, we talk about in stock markets, in e-commerce, in finance, in healthcare, in cybersecurity, in logistics, in agriculture, in practically all the fields. And then in power plants, it's been used for early detection of the faults, and in power plants and lines for demand forecasting, for real-time load generation balancing. This is an upcoming thing. It'll be interesting to hear you, sir. Please.
Thank you so much, sir. Can you please confirm if you're able to hear me all right?
Yes, sir. Loud and clear. Please go ahead.
Great. Thank you so much for that introduction, and thanks to CII for providing us with this opportunity to discuss what we think is going to be extremely important in the overall Indian power scenario. We've been looking at artificial intelligence primarily for power plants and how it could be adopted for flexible operations. And one point that you mentioned just now is actually what we wanted to talk about, meaning why has AI really taken this long? Like, we've been hearing about artificial intelligence for many years, almost 10 years, the largest of vendors talking about it. But what we feel and why we think right now is a good time is, one, there is definitely a need in the industry to use this to adopt to various challenges that are being posed to the industry. But one other reason is, I think earlier on, a lot of technology was being spoken about, but the depth of domain did not come across. So there were lots of platforms which could be adopted, but it didn't come with the flavor of the industry. So that is number one. But what we also think is very essential for adoption of artificial intelligence today is the people who are actually using it need to be involved. So we try to actually cover on these two areas when we built our solutions, which I'll talk to you about a little later. We primarily build AI solutions for the energy sector. We started with thermal power plants and with a very, very deep focus on the people that are using it. Like I told you, power generation, we also work in the oil and gas and iron and steel spaces. And our solution has already been used by the likes of ABB, ABG, one of the biggest OEMs of power in India, and also an Australian firm. So what I am going to really do today is probably spend around half the time that I have today on a few stories that we have come across through the last 4 years or so building this solution, and how we've enabled certain critical use cases for the power industry. And the latter half will probably be on the technology behind this. This one particular case, I think, is something that would ring a bell when anyone from a power plant sees it, especially with the flexible operation scenario. Few plants that we have been deployed at have been experiencing increased number of outages due to few failures, and this typically happens because of higher frequency of cycling of power or flexible operations. And what we realized is there are solutions today that is able to detect tube leaks, like there are sonic solutions, etc. And people keep asking us, can you predict tube leaks? But what we thought is very essential is not be able to predict tube leaks. That's going to help you with the planning. But can we simply help you avoid these tube leaks which may occur due to operational oversights, right? So that's what we want to focus on. So what we typically do is use all of the sensor data available. So a typical, coal-fired boiler would have anywhere close to 1,000 or 1,500 parameters, which consists of maybe 400, 500 metal temperatures, the entire flue gas profile, your steam profile, your flame health, your mills in use, and so on and so forth. Now, you could only imagine how difficult it's to be to monitor each one of these closely, right? So what we try and do is create profiles of a boiler, like you see on the screen over here. So using all of the data that I spoke to you about, we create profiles of various heat exchanger surfaces, right? And these profiles are created at various different loads or operating loads of the plant. And a system is basically looking at these profiles and changes in profiles, and also subsequent or prior changes in the system. It might be due to firing of a top mill suddenly, or increasing your burner tilt, or simply because the heat exchanger surface is not clean, or it might be because of an unbalance, right? So it is looking at the entirety of a boiler and not just singular trends of a sensor parameter, and is able to basically sense that something is really amiss when something like this happens. So if you look at the reheater section on my screen, this is the reheater section, the bottom left image from a normal operation. You can see what the heat distribution is really like. And the reheater heat distribution over here, you can also see it in an LTSH. So what really happened over here is 18 hours before a failure actually happened, our system actually detected this severe unbalance. And this was a time when there was I think, ramp down in terms of power, the load on the plant. and it created a lot of overheating on one section of the tubes in the reheater. And likewise, you see there is LTSH, which is completely, gone low on the temperature. So what's really happening with flexible operations is this cycling of loads create extreme stress. And there are interventions that are available at the hands of an operator to actually take care of this. So once this happens, there are ways you can actually try and mitigate the effects of this and set it right. But the problem really is this. Now, there is no way that an operator is able to look at so many alarms. For instance, a DCS would throw thousands of alarms every day, more so because of flexible operations. In this particular case, you see that the yellow band is basically the predicted range in which a plant is supposed to operate. And the reheater temperature has been operating in all of its past at around 600 degrees or so. And based on the DCS, the limit for that particular sensor might have been 780 degrees, right? So 600 to 780 degrees, DCS is not going to throw you an alarm. But what our system really does is it creates this band for flexible operation. So you see that the band is dynamic. This changes based on how the plant has operated in the past at varying loads, at varying conditions of the plant. And it immediately detects that there is something significantly wrong. This is about 18 hours, like I told you before the failure actually happened. And they continue to operate in this zone for almost 2 hours or 3 hours that you see over here. So all of this is automatically done. And expected enough, it went back into normal, but this overheating that happened here led to a failure here. And 1 day of downtime, you would know, is quite expensive. It could run into the crores. But more importantly, I mean, there is failure that you need to attend to. There is a danger related to this. So how do we really help avoid tube leaks or tube failures or anything with related to boiler is one thing. One case that we've seen in plants in India and in Australia as well. So this is one. And this case was more to do with reliability of asset, but reliability of a heat exchanger. So this happened with HP heater, where again, there was fluctuations in the feed water temperature to the economizer. Now it was going lower, but then typically you don't know, the actual value needs to be at various loads because you can't really refer to design documents at each time, and it's left up to the experience of the operator. But such variations, maybe 5 degrees or 6 degrees, is typically attributed to changes in load, or it would be considered normal variations. But we saw something very abnormal in all of this, and when we spotted that temperature was dropping, the system also identified that the heat exchange in the HP heater was not happening okay. So there were, the TTD was increasing gradually. And sure enough, so when we brought this to the notice of the plant, there was a maintenance planned specifically for this to see if fouling could be addressed. And, 6 or 10 degree drop in feed water temperature could be around 0.5 to 0.8 degree drop in efficiency of the boiler. Okay. So these are a couple of cases that we have come across. One last one, which we detected with a turbine bearing system in a slightly smaller plant. What I really wanted to show you is what this insight is really going to look like. So what you see on the screen is a little incident that we call in our system, which not only detects that there is a problem with the bearing. So we saw that the bearing temperature and vibrations were changing, but it automatically also scours through the entire system, downstream systems, upstream systems, everything, and detects these causes automatically. That's really where the domain aspect comes in. We don't want to be throwing thousands of alarms, right? In a day, if you have 10 useful alerts like this, it's more than enough to keep the plant running reliably. So there are automatic root causes which are detected and recommendation for the operations. And this is really coming from our library of digital twins, which have codified almost 1,500 different failure modes for a power plant. And these levels or changes or alerts are not coming based on thresholds like in your DCS, but based on predictive models which have learned about optimal behavior and relationships from your past and helps you avoid bad things from happening in the future. And most importantly, like I told you, when it comes to people, is how do we bring them into the crux of this? How do we give them a tool for knowledge management where experts are able to put in their decades of years of experience into a system to help the future workforce? So that's really where we stand here. There have been many more case studies across the plan, but that's typically coming from the depth of domain that we go into when we talk about artificial intelligence. Now, the strange thing is plants have been automated for the longest time. They have the most sophisticated control systems, and yet these failures happen, which gives us a sense that existing systems are not really meant for reliability of an asset. So if this is one screen in a DCS that an operator looks at, now you get 12 screens, and then you have 30 or 50 screens. This is all point in time information. There is no way an operator would be able to look at or even memorizing more than 5 parameters, knowing its history, knowing its near-term, long-term history, and leave alone, spotting issues from this kind of noise, right? Now, once flexible operations comes into the picture, it makes the entire thing more complex. Firstly, DCSs have alarms, but they're all threshold based. Now, what is the threshold for the 60% load versus a 100% load is not really configured in a DCS. So the DCS does not know. And naturally, there is a lot of stress because of so much difference that reliability really takes a hit. Now, that's really where we like to come into the picture. You have so much data coming from your assets. It is not that assets are not giving out signals, but it's just impossible for people on the other end to make sense of it at the right time. What AI really needs to do is sit somewhere between the data and the people and create patterns to discover or learn these patterns to predict failures, but not just stop there, also help diagnose issues using very, very deep domain. And like I told you, there is an expert, there is a young person in your operations team, there is a maintenance team. Can they really collaborate and troubleshoot together? So that's what an artificial intelligence system must be doing to your engineers and DCS. And this is really where we come from in terms of a thought process. We've tried to create a system which is able to take huge amounts of data. So from a 500 megawatt plant, we'd be looking at anywhere between 3,000 to 5,000 parameters coming in live, some at 1 minute, some at 1 second, so on and so forth. So the data infrastructure to manage this is what we focused on. But beyond that, everything else above this bottommost layer is focusing on how do I convert 5,000 odd data points every minute into maybe 1 or 2 alarms in a day which have root causes, right? So to that end, the semantic reasoning framework, it is a reasoning is a stream of artificial intelligence where the system is able to think like a human does. So as an expert, when you see your flue gas temperatures going amiss in your boiler, there are a few things that the expert seeks. So that is the part which our system is kind of automating. And it comes built in with knowledge of various asset classes that we encounter in a power plant, and really gives a software a very power plant like language to interact with the users. So that is the framework along with some thermodynamic knowledge. The machine learning framework is essentially how do I get all of these 5,000 data points and process them, run predictive models, do the comparison, pull out the right kind of root cause, refer back to my design, my past failures, so on and so forth, and give you that little snippet of knowledge. So in terms of our digital twins, we've built twins for more than 50 odd classes of assets, including your steam turbine, gas turbines, boilers, condensers, you name it in a power plant. So all of them are actually covered here. But they also constantly refer back to or have an understanding of the process itself. What is connected to what, and how does it impact all of this? How does that learning really happen autonomously is actually part of this machine learning framework. So like I told you, 5,000 odd data points coming in. You don't want to really use junk data. So you have to validate them as they come in. Fingerprinting is an exercise where we look at whether that particular parameter is okay compared to how it was in the past for that particular load range. So every single tag has a fingerprint which is compared to in real time. And machine learning is really used to make predictions. So I'm going to use different techniques, but ultimately I'm going to make a prediction of what my steam temperature is supposed to be at the end of one superheater, what my bearing temperature is supposed to be given certain atmospheric conditions, certain lube oil conditions, given the load of the plant, so on and so forth. So that relationship is what is learned in these machine learning algorithms. And finally, a little diagnostic, like in the lube oil leakage case, it came up with one of these root causes. So pulling out that root cause and really reducing the noise from almost thousands of parameters that we get from a plant to one single very useful piece of information. And this is probably my last part of what I'd like to do. And more importantly, is something that power plants need to start looking at, right? We're not looking at artificial intelligence really as a magic box, but a tool that could be used by power plant engineers to make their lives really easy. And that's really what we have done. While we've built all these digital twins and machine learning algorithms, we've really created an interface where engineers with zero knowledge of coding or data science can tell the system to say, okay, I want to predict this bearing temperature. And based on my knowledge, the bearing temperature should be influenced by factors 1, 2, and 3. Can you go and learn from the past what that relationship really is? So creating your own predictive models and to detect these root causes, create a very simple, fault-free kind of a system, completely based on UI, which has a language like a power plant, where you can just keep going and extending the existing fault trees or create new fault trees to say, okay, when this bearing issue happens, I would like the system to identify these possible root causes based on different data points. So again, zero code is what we're trying to do here. And at all times, keeping the focus on knowledge management. Now you have plenty of experts, say within NTPC and all the other power plants. Now, how does all of that knowledge, stay within the organization? It typically gets lost, down the line. So a way really for people to put in that information and digitize it so that it can be run automatically as the future workforce starts coming in. What you would typically look for in an AI deployment, at least what we focus on, is to reduce unplanned failures. Asset reliability is the key thing that we're looking at here, especially with flexible operations. So how do we help you maintain a reliable and safe operation is one. And we see performance gains really as a byproduct of improved asset reliability. So when we make sure that assets are always working in the best possible region at all times, it leads to improvement in your heat rate or your auxiliary power consumption. And like I told you, I think one thing that is really missed out from this entire artificial intelligence story is how do you really help your workforce collaborate and manage the knowledge and retain it in-house. So these are the outcomes that we would typically try and help our power plant customers with. So in terms of the team, we knew very early on that it's a very cutting edge technology that we're working on, but it really needs to be married with the deepest domain expertise. So Arun, who's one of the co-founders, and myself come with analytics background, but one of our co-founders is Mr. Bob Ananto, who you see in the middle, comes with close to 30 years of experience from NTPC and was last heading a very large German power organization. So that's really the marriage that's bringing this product out. That brings me to the end of the presentation. I'd be more than happy to take questions when there is, but I hope you found the few stories that I had to say useful and pick some ideas that you could use in your plans as well. Thank you so much for the opportunity.
Thank you, Mr. Rahul. We do have a lot of concerns with the kind of flexi operation that some of our machines are operating in nowadays, but I'm sure, flexible operation or low flexible operation, the predictive models that you talk of are really required in power plants. Thanks a lot for that interesting presentations. Mr. Anil, can we have the questions from audience, please?
Yes, sir. I'll read out, sir. First question is to IdeaForge. The question is like, have you considered application of track-mounted drone systems for visual inspection of generator plants in India?
I'm sorry, track-mounted drone inspections.
Yes.
Well, sir, I'd say that we are kind of working towards it, but as of now, it's probably going to take another year and a half to probably get there. But yes, that's one thing that might as well surface soon enough.
Okay. And another question for you, sir.
Yes,
is
sir.
any anti-collision device mounted on drones to avoid any accident?
So yes, sir. All the small category drones that IdeaForge produces comes in with an anti-collision system, which at any point of time, if there is a certain hindrance for the drone to fly ahead, the drone would stop there and then wait for pilot's assistance at the ground control station. So yes, they are small category drones. They do come with anti-collision system.
Thank you, sir. Now the question is to Siga. How will the Siga DAQ connect with thousands of electrical wiring in a PLC?
Yes, that's a good question. What we do is prioritize what is the most critical assets that we want to take and analyze. In cybersecurity in general, the key word is prioritizing. What is your most critical assets? And monitor those in the most precious way and the best way possible in order to get the best insights about your operation. So usually, as a thumb rule, we take about 3 to 8% only of the entire sensors and endpoints from devices from the level 0 electrical signals, and the rest we can also take from the network level if required.
Yeah, that's all from audience side, sir. I request Chairman sir to please conclude.
Yeah, thank you. I must compliment all the three speakers, Mr. Nagi, Mr. Sasnovich, Mr. Rahul Raghunathan, for very interesting and effective presentations. And we need to actually implement some of these in power sector. We actually need these. Drones are definitely being applied, but cybersecurity and the predictive models, this is something that power sector really need. Thanks a lot, and I want to thank CII for providing this platform for these interactions. Thanks a lot. So we'll close this session now.
Thank you, sir.
Thank you so much.